Hello guys, welcome to Backbencher Studies channel. In the last video, we discussed how we can plot the root locus. Basically, we used all the rules of root locus and we plotted how the roots are actually varying with respect to the system parameter gain or the system parameter k. So, how it is varying based on that, we solved how the roots are moving in complex S plane. So in this tutorial, we'll be solving about the frequency response of the system. So consider an LTI system, linear time invariant system with input x of t and output y of t with an impulse response of h of t. So the Laplacian transformation with frequency of S, we have the Laplacian transformation equations as x of s and h of s and y of s similarly. So if we kind of analyze this Laplace in Laplacian domain, what we have is the output of the Laplace transform of this output is equal to the transfer function multiplied with the Laplace transform of this input. So if we write this complex number as the magnitude and phase part, then what we have is y of s can be written as magnitude of y of s and angle of y of s. Similarly, we can write magnitude of g of s and angle of g of s, magnitude and x of s, angle of x of s. So if we kind of equate the magnitudes, then what we have is the magnitude of the signal will be magnitude of this input signal multiplied with this magnitude of the transfer function. However, the phase will get added with the phase of the transfer function. So this is how the linear time invariant system phase will be added and the magnitude will be multiplied. So in the S domain, what we have is S equal to sigma plus j omega, where sigma is responsible for damping or it is exponentially varying term. However, this j omega is a complex sinusoid term which gives us the complex frequency. So the frequency response deals with when sigma equal to 0, that is there is no exponential variation, that is only we had the sinusoidal frequency term s equal to j omega. So to find out the frequency response of the system, what we need to do is we have to substitute the uh, s equal to j omega in this transfer function equation, and we have the frequency response of the system. So this is how we can define the frequency response of the system, and this is how we can find out the output of the system, the magnitude of the output of an LTI system and the phase of the output of the LTI system. So that's all for today, guys. In the next lecture, we'll be solving and we'll be discussing the frequency response, why it is defined as the steady state response, and what happens if we gave a sinusoidal input. So thank you, guys.